These are Algebra 1 notes for 4.10, Graphing Solutions of Systems of Inequalities. So before we get into the systems, remember a system is two or more, and in this case it would be inequalities, not equations. Two or more inequalities with two or more variables. So two or more inequalities with two or more variables. And just as a reminder, an inequality is going to be less than or equal to, greater than or equal to. We would use those symbols in place of the equal sign. Now, this is again a little refresher from previously. When we graph an inequality, if we have a less than sign, it's going to be shading below the line, and it would have a dotted line on it, and then if it's a less than or equal to, it would be below the line with a solid line. If it's a greater than sign, we use a dotted line and shade above, and greater than or equal to has a solid line. Now, if you have trouble remembering the ups and the downs, you could go like this with a greater than sign, and it spells the word up to help you remember that we shade above the line. If you have a less than sign, we can put a line on it and spell the word down to help you remember to shade below the line. So let's do the little example here. This is just graphing one inequality. So we have y is less than or equal to 3x minus 5. Now, just like we do with equations, we're going to graph the y-intercept first, which is minus 5, and then we're going to use our slope of 3, which is 3 over 1, and we're going to go up 3 over 1, up 3 over 1. We're going to keep graphing, and then since there's an equal to sign on this, we're going to graph a solid line. And now I want you to look at the y-axis, because since it's a less than or equal to sign, we want to shade below the line. So here's the y-axis, and you look at the y and say, where is that y-axis below the line? Well, it's down here. So this is going to be the area that gets shaded. And there's lots and lots of solutions. There are lots of points that are below this line. We can pick any point that's in the shaded zone, and it would be a solution to this inequality. Now, I also want to remind you that when you have a solid line, points on the line are solutions. If it's a dotted line, points on the line are not solutions. Okay, now let's go down and try a system of inequalities where we're going to graph more than one at the same time. Okay, so we're going to graph two inequalities. The first one is y is greater than 1. So this is a special line because there's no x in it. It just has a y, which means it's a Hoy line. A Hoy line is a zero slope line, and it always is y equals. So it's going to be a horizontal line going through the 1. And because it's a greater than sign, we know it's going to be a dotted line because there's no equal to sign, and we're going to shade above the line. So let's go ahead and draw our line, dotted. And the solutions to that inequality are all above the line. Now the second one is x is less than or equal to 1. So on this one, it's a special line as well, because there's no y in it, which means it's a Vux line. And we're going to make it go up and down. And it's less than or equal to, so we know it's going to be a solid line, and we're going to shade below. So let's go ahead and draw that one. Solid line going through the 1. And we want to shade, well, I said the word below, but it's really to the left, because when we're talking about x's, we go left and right. So it's going to be left, and the solutions to this system of inequalities is going to be the place on the graph where it's double shaded. So I'm going to write that down here. Solutions are in the double shaded area. So you can see on this one, that's up here in this corner right here. It was shaded up and down there for the first equation and left right here. So any point in this area is going to be a solution. So solutions are in the double shaded area. They're also, if there's an intersection point, if they're both solid lines, then that would be a solution as well. Not solutions would be if it's only half shaded, you know, was shaded for one line but not the other. If there's an intersection, if one of them is solid and the other one is dotted, then that point in the middle is not a solution because they both have to be solid to be solutions. So let's just look at this one. Points in this shaded zone are solution. Points along this solid line are solutions. Points along this dotted line are not solutions. And this point right here where they intersect, not a solution because one of them's dotted and the other one's solid. So here's your solution zone in here. Okay, let's try the second one. It says y is less than 3. So again, this is a Hoy line. So we're going to put a dotted line on 3. And we want to shade below the line. It's a less than sign, so we're going to shade down. Now, for the second equation, I'm going to get rid of some of this, what we have here. For the second equation, we want to solve it for y before we can graph it. So we have 8x plus 4y is greater than or equal to 12. So let's take the x over. We're going to subtract 8x. These cancel out. So we have 4y is greater than or equal to negative 8x plus 12. And now let's divide everything by 4. Y is greater than or equal to negative 2x plus 3. So we're going to graph. I'm going to use red on this one. So let's put a point on the 3. And then our slope is negative 2. So we're going to go down 2 and over 1. 2 over 1. We want to have negative slope like that. And since it has an equal to sign, it's going to be a solid line. And then we have a greater than or equal to sign. So greater than or equal to means shade above the line. So let's look at our y-axis right here. Where is the y-axis above the line? That's going to be up in this zone right here. So I'm going to shade above the line. Now, where is our solution set? Where did it get doubly shaded? Well, that's right in here, right in this little corner. So what you maybe want to do is make the actual solution set a little darker when you shade it than the others so you can see exactly where it is. And now let's pick out a point that's a solution. This would be a point at, that would be 1, 2, 3, 4, 5, comma 1. That's a good solution. We could have a solution down here that's on the solid line. And we can have solutions all through here. But where do we not have solutions? Well, on the dotted line are not solutions. And at this intersection point, not a solution because one of the lines is dotted and the other one is solid. Okay, let's go to the back. Okay, so on number 3, we want to graph this. So first thing we're going to have to do is solve for y. Now you need to be careful on this one. It's got some trickiness to it. let's take a look. So we have 2x minus 2y is greater than 6. So we're going to take the x over, subtract 2x. Make sure you bring your negative sign down. So it's negative 2y is greater than negative 2x plus 6. Now we're going to divide everything by negative 2. And this is where it's a little tricky. Remember, when we're dealing with inequalities and we divide by a negative sign, this sign is going to flip. So we're going to say y is less than, and now we have negative 2 divided by negative 2, and negative divided by a negative is a positive, so that's going to be positive 1x, and we can just write the x like that. If you want to put the 1 in front of it, that's fine, not going to hurt it, and then minus 3. So let's go ahead and graph that. So we're going to graph our y-intercept, which is negative 3, and then we have a slope of 1 over 1, positive 1. So it's going to go like this. Dotted line, because there's no equal to sign. And let's look at our y-axis. Where are the y's less than this line? Is going to be below. We're going to shade below the line. Now let's do the second equation. Y is greater than 0. Now this is a special line because the only thing that's there is a y, so that's going to be a Hoy line. So that's going to be a dotted line because there's no equal to sign, and it's going to go right there on the axis because it's 0. And so there's our dotted line, and y is greater than this line. So I'm going to shade it like this up here. So where's our solution set? Is going to be this little corner right in here where it's double shaded. Now remember, this line is going to continue on forever, and this line here is going to continue on forever. So your shading continues to go over here like that into infinity. But on our graph, we have these points right in here as solutions. Now, are solutions on the line, are points on the line solutions? No, because it's a dotted line. How about on this line over here? Are they solutions? No, it's a dotted line. And of course then on the intersection point, it's not going to be a solution either because they're both dotted. Okay? Let's try the next one. It says y is less than or equal to x plus 1. So if y is less than or equal to x plus 1, let's go ahead and graph our y-intercept is 1. And then what's the slope of that line? What number's in front of that x that we don't see? Well, it's a 1. So we have a slope of 1 over 1. That's going to be positive slope going up 1 over 1, 1 over 1, like that. And all the way down. We're just going 1 over 1, 1 over 1, 1 over 1. And it's less than or equal to, so that's going to be shade below the line. Oh, you know what? Here I am saying dotted line. It's a less than or equal to sign. So bam, there you caught me in a mistake. Should be a solid line. A solid line because of the equal to sign. Now let's do the second one. Now we can't graph it yet because we need to have it solved for y. So let's subtract x. So I have y is less than negative x plus 6. So what's the slope of this line? Is going to be negative 1, and we can put negative 1 over 1. Now this one is going to be a dotted line. Okay, so we're going to go up here to the 6 and put a dot, and then we're going to do Negative 1 over 1, like that. And we want to shade where it's less than, and so that's going to be below the line here. So where is it doubly shaded? Right in this corner right here. So all these points inside here are going to be solutions. Solutions on the solid part of the line, but not solutions on the dotted. Those are not solutions. And the intersection, not a solution, because one of them's solid and one of them's dotted, and they both have to be solid in order to be a solution. Okay, let's look at number 5. Okay, look at number 5. It says, without graphing, explain why the point where the boundary lines intersect in this system, 2x plus y is greater than 2, and x minus y is greater than or equal to 3, is not a solution of the system. So I want you to think about that and write your answer down. What do you think? Why is it not a solution? Well, one of them has an equal to sign, and the other one doesn't have an equal to sign. So whether they were less than, greater than, whatever, since one of them has an equal to sign, that's a solid line. The other one's going to be a dotted line, and the intersection point is not going to be a solution. They both have to be solid lines if that intersection point is going to be a solution. So because it's one of them is solid and the other one's dotted, it's not a solution. Okay, let's look at the last one. Now you're going to have a question like this on your homework, so you need to pay attention. So let's try it. Now it says, for which point on the grid satisfies the conditions x is less than or equal to negative 6 and y is greater than or equal to 1/2 x plus 5. Now one way you could do this question would be to look at all the coordinate pairs. And so, like, let's look at point A. If we were to find the coordinate pair, that would be 4, comma, and it looks like 6.5. 4, comma, 6.5. So you could plug those in and see, does it satisfy both inequalities? So if I were to put 4 in here for x, because this is x and this is y, is 4 less than or equal to negative 6? Well, it certainly is not. 4, the positive 4 is greater than negative 6, so that one doesn't work. And so both of them would have to work. 6.5, where this one's y, 6.5, if I put that one in, it would work, because a half, actually I tell a lie. If we were to put 4 in for x, I would do 1/2 times 4 plus 5 needs to be, 6.5 needs to be greater than that. So if 1/2 times 4 is 2 plus 5 is 7. 6.5 is greater than or equal to 7. Is 6.5 greater than 7? No, it is not. So it's not going to work for either equation. Now that's one way you could do it. The other way would be to just graph the inequalities and see which one of these points ends up in the double shaded area. So I think that's what we're going to try. Let's start with x is less than or equal to negative 6. Okay, well, if it's less than or equal to negative 6, this is a Vux line, so it's going to be straight up and down. And we're going to go over here to negative 6. 1, 2, 3, 4, 5, 6. And we're going to put a dotted line. And we want to shade where the x's are less than that. Well, x's go left and right, so these are the ones that are going to be less than that. So already we know that this point doesn't work and that point doesn't work, because it has to work for both equations. So those are not in the shaded area, so we know they don't work. Now let's do the other one. It says y is greater than or equal to 1/2 x plus 5. So first we're going to plot the 5, and then we're going to do 1 over 2, 1 over 2, 1 over 2, 1 over 2, like that. And we're going to draw a solid line, and we're going to shade, because it's greater than or equal to, we're going to shade above the line. So here's our doubly shaded area right in here. So we can see that the only point that works in the doubly shaded area is point B. You can see it there. That's the one that's getting double shaded. So the answer is B. Okay, so that's your lesson for the first day of Systems of Inequalities, Day 1. We'll be doing more tomorrow, so good luck on your homework.